In this section, we'll be talking about graph databases, specifically Neo4j. Graph databases are very different from a traditional relational database, such as MySQL or Oracle. A graph database can be leveraged when your data model doesn't quite fit into a relational data model. In this section, we'll look at graph databases and how they're different from relational databases. There are fundamental differences, most obvious in how data is related to other data. In this video, we're going to talk about what is a graph database, what makes it different from relational databases, document storage engines, and other data stores. Data modeling is the problem that causes us to need a graph database. We'll get into how data is modeled for relational databases versus graph databases, and we'll talk about a few high-level examples that fit a graph model well. Relational data models force us into a very strict structure of rows in tables that can relate to other rows in other tables. Relational data models force us into a very strict structure of rows in tables that can relate to other rows in other tables. There are different patterns of joining data together, depending on the type of relationship, whether it's one-to-one, one-to-many, or a many-to-many relationship. Rows in a table can relate to other rows in the same table to form a hierarchy, but going beyond one level implies a recursive relationship, which can get extremely tricky in a relational database, especially when there's an unknown depth. There are many applications of data that focuses more on the relationship as opposed to the actual data. Think about Twitter as an example. The users and tweets are the data, but the real value of Twitter, the users and tweets are the data within Twitter, but the real value that it provides is around who follows whom, who likes what tweet, and who retweeted a tweet. The overall value and innovation of the platform has to do with the relationships of the data, and an application can be built around the relationships and their attributes. Relationships and data can come and go. Data can change over time, as do the attributes related to the relationships. In our data model today, a person may drive a car, but tomorrow a person will just own a car and ride in it, and may no longer be able to drive it. The real world changes, so having the ability to build flexible and changing relationships within a data store helps us model the real world. Data also changes. Traditional databases have very strict definitions of tables, what columns are in that table, what data type each column is, and therefore what data gets put into each row. This is changing now with innovations like JSON data types within Postgres, but having the flexibility of a document store or a database without a predefined data model allows for quicker implementation and changes to an application. This is one of the many great features of Neo4j in particular.